Alright, hello everyone. What's going on this fine day? Let's see about getting started here. How are the audio levels? You might have noticed that I actually switched out the music a little bit. Let's maybe put down the volume a little bit for the music. Do let me know if this is listenable, if you can hear me all right, and all of that. So, welcome back for some more game dev. Today we're gonna be doing game dev in the most honest and truest sense of the word. I'm gonna be writing some gameplay code here. And so that's nice because we've been doing a whole lot of, well, tech work and also some game content stuff. Last time I did game stuff, but it wasn't programming. It was content stuff, which is fine and it's fun to do on stream. But today we're gonna attempt some honest to god gameplay programming here. How about that? Let's make sure we can actually run the game first of all. Maybe I should go in and actually export the level here to begin with. So this stream is coming off of a week of optimization, basically. I've been optimizing the renderer for the past week or so, and so whole lot of changes. Let's hope it doesn't break. Let's hope it stays up. I'm kind of waiting for these thumbnails to be rendered here. That's fine. Let's open Depot. Depot is a nice and small level that is kind of easy and quick to work with, but it's still reasonably detailed. And we should just wait for it to render the light probes there. And we can export this guy and then actually play the game. I think before we do that though, we might want to actually do one small thing here, because currently when we launch the game, if we go here and we make sure we build this, I think I might have already done that actually. Yeah, we have this play level launch argument here, which just basically takes us right into the depot level when we launch the game. Let's make sure we can actually launch it. We should be spawning under the camera should be under the ground here. Yeah, looking up, which looks a little weird. And then we can just run this dev command here, which actually gives us a car and spawns us here where we are sort of used to being when we start this level, right? I think I'm gonna want to actually make it so that we do that automatically. It's just easier. So this guy sits on a layer called test vehicles, and I think we'll want to actually have, let's see, here's a dev helper. Yeah, so let's just make a quick script for ourselves here, or a small change to the script, so that we don't have to run that every time. We can actually just get that vehicle automatically, and we can do that by adding here an on message received, and the message that we want to actually listen to is game started. I think actually that message is found in the standard. It's called something standard. Let's see if we can find it here. Game UI. It's not a UI script. Maybe I actually took it away. I used to have like a nice little constant for this message because this is just a random string here, but I just happen to know that that thing is there, right? And so we can check here if self campaign active is what's it called, is campaign active. So if not campaign active, right, then we just want to do the load test vehicles like this, and that should just basically give us a vehicle if we're not playing this mission as or through the single player campaign, which we won't for a while still because it's not really hooked into the campaign or anything. But now we'll run the game, we should get our vehicle immediately like this, which is pretty nice. All right, so with that little thing out of the way, I mentioned some time ago that the mother vehicle, which is this big yellow vehicle thingy that we can find here, which is also part of the test vehicles. Hello, mother. And ask the mother to come to us, for example. The mother has this crane on the back there, which is this classical magnetic cargo crane sort of thing. And of course we can use the cargo crane if we want to do all sorts of things. We can, for example, if the vehicle would stop rolling, thank you. Use the cargo crane to pick up the vehicle, for example, or we can pick up other cargo. The cargo crane is pretty limited though, in that it essentially only picks up like one thing at a time, right? I don't even remember what the key for that is with the keyboards. I better just use this gamepad here. Anyway, we can pick up things like this, and you can even pick up other cars. But we do have a need in the game to pick up just lots and lots of smaller objects. And with this one, you can only essentially pick up one thing at a time. You can, however, pick up like a container, and then, you know, in that container you can have other things. You know, that's possible to do. But still, it's pretty much sort of like a one thing at a time crane. And I do need a crane to pick up just like a whole bunch of things at a time. So I was thinking we would add another crane to the mother vehicle, and I think actually that crane is one that is going to be like the first one you have. I think this cargo crane here is something that you're gonna get like a little later in the campaign actually. And so I think we're gonna start looking at that other crane today. Actually implement it. And it should actually be, like, I should say, considerably simpler to program than this one. This is actually kind of a complex thing, especially when you start, you know, extending all of the cable here. There's just like a whole bunch of physics joints and things happening here. I think the maximum number is probably something like 50 or something. Physics joints making up this cable. You can see it intersecting the visual mesh there a little bit. Yeah, that might have to do with the fact that the collisions for the mother vehicle aren't necessarily all that well done. Well, they kind of seem to be actually. I don't know why it does that. That's not really like a big problem though. Anyway, we have physics joints distributed along that cable, and so if you have a really long cable and then you do something like this where it, like, you know, you have the cable out there on the ground, and then you start driving away. There's just a whole lot of interactions happening there at once, and then it will probably start, like that car will start bouncing around the place essentially, looking stupid. There's a little bit of wonkiness here. I think this new crane will actually be kind of simple in the physical sense, right? Because it will be essentially sort of like a gravity distortion field crane, in the sense that it will just have some sort of device here at the end of the arm, and then that thing will just like pull small things toward it. So you won't be able to necessarily lift things like cars with it, but you will be able to lift smaller things like crates, stuff like that, and just have like a whole bunch of them at once in the air. And so, of course, like in real life, that would be kind of a tricky thing to implement. I don't think there really exists anything like that in real life, but when it comes to like implementing it here in our game, it's actually pretty easy compared to like a crane with a cable, which is not a very tricky thing in real life. The irony of that. But yeah, we can see that we have a few of these hard points, or sort of like sockets here for the cranes. I don't actually exactly know which one I'm gonna put the other one in. It's gonna go here on the side or on the back. Maybe it would be handy to have it on the side, just so that we don't make it too crowded there in the back. I think that might make sense. And then, of course, we have some fun things ahead of us. Things like what happens if we have another crane there, and then this crane actually kind of like starts poking at this other one. There might be like a whole bunch of fun bugs there to fix and look at. But I think that's for a later date to think about. Today we're just gonna start actually implementing this thing and see where that takes us. So let's do that. So basically what I'm talking about is like if we let this go, right? And then let's pretend we have another crane here. What happens if you do this? You just like, you can just about reach this place with the crane. Maybe that it has to sort of like prevent that from happening. You have like a whole collision mesh, separate collision mesh for where this crane is actually allowed to sort of move. So here if I just move this crane down here, it kind of like slides off that edge, and then the arm can actually intersect, but the end of the arm cannot intersect. So I might have to just modify that so that, you know, we can have that other crane there and it's not gonna break the whole setup of this thing. Something like that. I don't know. We'll see. We'll see. So I was thinking we would actually look at some very, very old code that I wrote. I've actually implemented this sort of gravity anomaly thing previously. And it wasn't actually very tricky, because like I said, we don't have like a whole bunch of joints. We have a few joints, but we don't have a whole bunch of joints. With this sort of gravity anomaly crane. I think it's actually here in Zig components. I think it's essentially like the only sort of Zig component present in Project Slide, which is the earlier incarnation of this game. Let's see what we have. So this is using now, this is not something that would actually compile today. So that's why we're looking at the code here rather than actually trying to run this thing. So it is essentially like the same game engine, like just like a version from maybe 4 years ago or something like that. So a lot of this will actually look sort of similar to what we have today, but for probably like hundreds of reasons this wouldn't compile, because the APIs have changed, you know, in 100 small ways. So what do we have? We have a Zig Crane control system component, and we have a Zig Crane avatar component. I think this avatar component thingy here is really just kind of like for input. So let's see. Send camera parameters, right? It controls the camera. Thick crane input, yeah. Yes, we have up, down, and forward, backward. Those are like move crane vertically and move crane horizontally. And then we can toggle the crane, I call it attractor here. So the thing that actually sort of pulls things, yeah, you know, toward the crane. And then this guy gets a pointer to its body, the crane control system component. That was this other one. And this other one has kind of like, you can see that it has a setup that is a little perhaps similar to what we have today. We have an arm with some bones. We have some render data, arm bone render data. This is probably just, yeah, it has like a mesh, material mesh instance. We have better ways to deal with that these days. We have some propagated values, because this is the whole thing is networked. So rotation angle, whether or not the attractor is active, and then some IK target position stuff. And then I think the meat of this guy is going to be here in the updates or the ticks, probably the ticks. Yeah, update attractor. So I think this is the thing that actually like pulls stuff towards it, right? Let's go have a look if I can manage to move there. Here we go. So yeah, we have a rigid body that we quite simply just move to the position of the sort of the tip of the arm, and then we have a radial force. And I bet this minus 300 is actually like it's negative because it's pulling rather than pushing, something like that. Well, we're gonna have to see how that actually works. Then we do some IK stuff. Whether or not the attractor rigid body, that's like a separate rigid body that this guy adds to the end of the crane. Might have to do that, or we might not have to do that. That remains to be seen. Destroying the arm visuals, creating the arm visuals. So we acquire some meshes, we acquire some resources, materials, and then and we'll create some mesh instances with that. Create dynamic mesh instance, then we attach them. That would be the arm. The attractor body is a sphere, and it's a kinematic body. So we need to sort of move it ourselves through the world, at least here in this version of it. I'm thinking here actually, I'll probably what kind of would make sense to do is to have the arms have collisions themselves. Kind of sounds pretty sort of obvious perhaps, but it's not really something that like necessarily happens automatically. I think that spawn point might have to be kind of moved up a little bit, does it? This thing kind of jerks a little bit when it falls down in the beginning. I don't know. Whatever. Yeah, it's probably just the fact that the frame rate is kind of bad there in the beginning. And we load stuff that's not really like coming through the level. We load it through a script, and then it's kind of like awkward when it spawns in. Let's not worry about that for now. So this guy actually has, if we kind of position this close to something, I'm gonna have to stop you right there so it doesn't roll down the hill. Right, this guy actually has collisions like you would expect. So if we nudge this, you can see the whole vehicle kind of like getting hit by that. And so rather than having like a physics body there at the end like we had in that old version, I think these days we would just have it sort of be part of the body there for the sort of what is it called, like the end of the arm. So we have a few bones here, as they're called. We have this bone, which is the sort of like inner part of the arm, and then we have this top piece here, which is sort of like the outer arm of the outer part of the arm. And the way this guy actually moves is that you sort of control the end of this arm. So if we move it like this, we just move the end of the arm straight down. We actually move it down straight down in vehicle space, and you can see the vehicle is kind of slanted, so it doesn't move in world space exactly up and down. But still, the idea here is that you move the end up and down, and then the arm sort of like IKs in such a way that it sort of reaches for that position. If you imagine sort of like a slightly slanted line like this, you can just move the end of the arm along that line. And then you can also just rotate the thing. And then the arm just tries to make it possible to have the end at that position that you want. And that way, sort of like what you care about, which is typically the end of the arm, is the thing that you actually control, right? And then the arm just sort of tries to satisfy that requirement, if you will. And I don't think we really need to change like a whole lot about how this thing controls. I think it controls quite nicely. You can even like poke the ground with this thing and make it sort of difficult to drive because you're sort of poking the ground there. All of that works, and it kind of behaves the way you would expect it to. So that's okay. Yeah, let's go back to the code here and let's see what else do we have. So update arm rotation angle, that would be like the horizontal thing here, blip, 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 like that. And then create some scene nodes. Move arm. I think move arm is probably actually called from that other guy, from that other component that we looked at. So let's go have a look here. Yeah, you can see here. Here's move arm. Tick crane input. I don't think we need two components for this these days. And then return to rest pose. Sets a boolean. That's kind of strange. But yeah, this is really old code. But the kind of important thing here is that, like, okay, if we want to have this sort of like attractor thingy, like this line here is the most important of the entire component, right? It applies a radial force at the position of the end of the arm, right? So that's what we want to do. And essentially we could just, copy this crane thing here and just add like that line. So rather than having like a cable and a magnet here, it doesn't have them, but it just runs part of the code for the end of the arm, and might sort of like, at least conceptually, sort of do that. Just copy that code, but since actually creating this crane, this is now the code that actually runs and compiles. So this is the code for this cargo crane. You can see that this component is pretty long, it's pretty large, it's 482 lines. It's not super large, but it's pretty large, and it uses two pretty significant pieces of code that's actually not in this file. It uses a 2-joint crane arm, and it uses a crane cable magnet assembly. Well, this guy we don't need at all. It is specifically the part that like makes the cable and the actual magnet at the end of the cable possible. We don't need that. We might want to use the 2-joint crane arm, but I think we're going to create a better version of that. Because there's like a few things with this crane that I kind of need to fix at some point. You can see that like every now and again the movement of this crane is a little jittery. Right now it's actually, at least here on my screen, it looks like it's moving completely fine, but there's a little bit of jitter every now and then. That has to do with the fact that the movement is actually not interpolated like the rest of the visuals in the game. And so that would have to be fixed. And that's specifically like the crane arm movement isn't interpolated. If we drive here, the movement of the entire vehicle is interpolated, and the crane is sort of attached to that. So it will just look nice and smooth. But the actual crane's own movement, sort of with respect to the vehicle, those aren't interpolated. So every now and then you get a little bit of jitter in the movement of the arm. That's something that we should fix. And I have some code for dealing with that these days. That this crane actually doesn't use. Hey Matt, welcome back. What's going on? So this is a pretty good piece of code. This two-joint crane arm thing. This is a pretty good piece of code, and it's a pretty significant piece of code. It's almost 1,000 lines, 873. So well, not quite, but pretty close to 1,000 lines. And this one does essentially like the IK part of the crane. So yeah, now we can see maybe a little bit of jitter, and now it sort of went away. And this thing actually uses something called a graph. So we have graph nodes. They're essentially like scene nodes, like a transform graph or scene graph, where we have a root, we have an offset. The idea behind the offset is of the node is to allow the joint between the root and bone to be offset from the center of the root. So the root is probably like, let's fly a bit closer. The root is probably like in the middle of this round piece here. And then I think the offset is sort of like in the middle of this piece here. And then we have, after that, we have bone 0, we have bone 1, and we have arm end. So bone 0, I think, is sort of nested here. Bone 1 is nested here. And it is this top part here, and then the arm end is where you would expect it to be, right? That sort of thing. And then this graph is used to actually drive. We have these scene node pointers that we actually use to drive both the physics and the visuals, right? And this works, but like I said, this is actually not interpolated. I made a new piece of pretty handy code, if I can remember where it is. It's maybe in Probably means lib. Yeah, articulation graph. So the articulation graph is a small piece of code. It's actually not super large, but it handles some of the tricky math that you need to actually sort of solve to have this sort of like graph of physics objects that make up, you know, something like this, like an articulated piece on a vehicle, so that it can move and sort of move other pieces around, right? And it's a graph because, like, if we rotate the root, you can see the whole thing rotates and all of that. But essentially, you could, like, at least in theory, you could move just this top piece while this bottom piece stays in place, right? And this graph kind of like allows you to do that. So you kind of just tell the system, update joint drive goal pose. Right, you tell this thing to update like a certain part of the graph, and then it kind of figures out, you know, the actual drive goal pose for the joint. So this joint here is like a phys X joint. It just makes it easier to have this sort of like nested bodies nested under other bodies and moving together in unison. But this thing is actually not used for the crane, like I said, because this articulation graph has like the graph here. Here we have the graph size, and then the actual like physics parts and all of that inside of the articulation graph. But this cargo crane component just has essentially like the same thing outside of it. What actually does use the articulation graph is things like the gripper truck. So the gripper truck has sort of like a similar thing here in the front. It has a gripper arm, looks like this, that also has things like nested under well, in sort of like a graph-like way. If you move the whole thing from the root, and the root is of course here where it's sort of like fastened to the car, the entire gripper arm moves. But then if you move just these claws, then, you know, the claws along with their physics bodies making up these kind of fingers, they move, but the rest doesn't move. That sort of thing. And this thing actually uses the articulation graph, so we should use that for the new crane as well. Gripper, oh, that's not how you do it. Gripper arm. Gripper truck arm. This thing, this is actually probably, yeah, this is even longer, 696 lines for this gripper arm. And this guy uses the articulation graph, and we should look at how it actually does it. So it has an articulation graph, and you tell it sort of what is the graph that we want. Well, here we have just like arm, left fingers and right fingers. Those are all the sort of moving parts of this gripper arm. We have the arm, which is essentially sort of like this yellow part here, and it moves everything together. And then if we open and close this guy, we have two other pieces, and they can sort of move sort of independently. Zig asks, you Finnish? I am Finnish, yes. Or Finland Swedish, to be specific, but yes. Right. So yeah, we only have three sort of pieces here making up the graph in this case. So we would have something similar like this. We would just create a graph and we would feed it to an articulation graph. And let's see, what do we do with the articulation graph after that? It's been a while since I wrote this. So we need to call create, and we need to call destroy, and we need to probably feed it sort of like the scene nodes that we wanted to actually yeah, create graph is here, right? So after you call create, I think this is actually like listed in the comment there above the articulation graph. Let's see, where's create graph called? Yes, okay. So when we create this component, this create function is first created, and we just set up a whole bunch of like getting pointers to the physics engine, physics scene, blah blah blah, game object. Then we call articulation graph create, and then sometime later, when all of the components of the game object have been created, this on object created is called, and here is where we call create graph. And here we can now actually create the actual scene nodes for this. We have the arm, we have the left fingers, and we have the right fingers. And then we just assign them to scene nodes with the correct index. Let's see. Looks insane good. Looks insane, man. Good job. I can't even imagine how hard it must have been to implement all of this. It's pretty difficult sometimes. Yeah. Yeah. The stream came into my recommendation for some reason. Damn, it looks complicated. It's not very complicated. I mean, yeah, sure, yeah. Like some of these vehicles actually are you know, kind of complicated. Like this guy here, for example. It has a bunch of things that I call rolls, so you can drive around the thing. You can drive around the thing just like essentially like any of these vehicles. And if you do that, you can put, you know, put cargo in the back. Let's see, where's that? I think that's a small one. Yeah. Put a few small crates there in the back. And now I can drive around your cargo. They sort of like bounce around realistically how you would expect them to. Kind of behaves how you would expect physics objects to do, at least most of the time. But then we have some other things. We have the gripper arm, which we already looked at. So if we put down like another one of those crates there, we can just drive up to it, and we can press. Is it maybe that one? Yes, it is. I don't remember these buttons anymore because I haven't really done any gameplay for a while. So you can just have the thing sort of lifted into the air, and we can load it into the back if we want to. Things like this. Then you can, you know, unload the cargo whenever you want. Reset the thing, and then you can again drive away. So this vehicle has quite a few of these sort of like features. Not all of the vehicles have this many. Scout essentially has none. It has just this is just a car. You can just drive it around. And so yeah, this might look complicated, but I mean, as gameplay code goes, it's not super complicated. There's a bit of 3D math to figure out, you know, where things go in the world and how forces are applied to them, stuff like that. So, I mean, it's kind of inevitable that there will be code when you're doing things like this. So it might look a bit complicated, but you'll manage. You'll manage. Anyway, so what we do here is that, okay, we have created the graph already, even though this is called create graph. We have created the graph here by calling articulation graph.create. And since we fed the actual like graph layout to it, we know that it's going to have an arm, it's going to have left fingers and right fingers. And here we create the actual like scene nodes, essentially, right? So we take graph root, we create a child node, and we set the position somewhere. This is probably like kind of like offset from the from the center of the vehicle, most likely. So like if the center of the vehicle is here, then I would assume that this arms offset is probably like in between, you know, these two sort of fixtures. So there's one on each side, right there in the middle. That is kind of like where the root for this guy is. And then we have left finger's fixture position is probably offset from that one, right? So it would be like there, and then the right one would be there. And then we assign them. And then after that, I think the only thing we need to do, we need to create the physics parts for each of the nodes that we actually, you know, want to have physics. You don't necessarily need to have all parts have physics. I think for the crane, you know, this piece here needs to have physics, and this piece here needs to have physics. You can probably actually see them if we turn on. Right, we need to run the game with the server running on the main thread. So let's make that happen. We just need one additional launch parameter for that. So if we turn on the server physics and look at this, we can actually see that this guy now has physics. Like, annoyingly, PhysX, which is the physics engine I'm using, it renders these things called the... what are they called? It's probably like mass frames, I think. And mass frames are pretty handy because they show sort of like the sleeping or non-sleeping state of these objects. So you see this kind of slanted box here is the mass frame for the vehicle. They're not actually the collisions. The collisions are these sort of magenta reddish things. You can see that they match sort of like the outline of the vehicle in a much better way. And so you have things like this where it's just sort of like, what is that? Well, that is the mass frame for this crane. So it looks a little strange. And if we start moving it, you can see that it kind of comes to life, and then it at some points falls asleep again. I could maybe turn off the mass frame visualization there. Might be a little easier to see what is actually going on. Let's see if we can find it here in the C++ code. I think it's called mass frames, isn't it? Mass frame, maybe? No. Let's go to scene PhysX5 visualizer. Maybe a flag like on the dynamic body. Let's see if we can find it. Visualization. Here we go. Body mass axis. It's not mass frames actually. We comment that thing out. We should see only the collisions. I think that should make it a bit clearer what's actually going on here. So now we can see that. Okay, now we have these red sort of shapes all over the place. Now these are the actual collision shapes now. So we have one shape here for this bottom part. We have another shape here that sort of like intersects the thicker part of the top one a little bit. But you can see it here when it's in its narrower at its narrower end. And then if we extend the cable, you can see that the cable is sort of like made up of this. Look almost like sausages stringed together. So that would be that. Anyway, I'm not sure how well I'm actually like explaining this articulation graph stuff to you, because I'm sort of rediscovering this again after a little bit of time myself. But the point here is that like a whole lot of stuff that we do here in the cargo crane component, which is this older crane, this crane which already exists, can now be done just by using one of these articulation graph things. So we should definitely do that. Anyway, yeah, we can call create physics on the parts. So here, for example, we're doing the left fingers. We're giving the parent actor, which would be the arm. So again, we're talking about the gripper truck here. Gripper truck like this, and we can see that this guy also has just a whole bunch of small physics bodies here for its arm. Oh, put the handbrake on for this guy so it doesn't roll down the hill. So it has just like a whole bunch of these shapes here making up this arm, and when we actually move this thing, it moves those shapes around like this. Right. And yeah, you don't need to create physics for all the parts necessarily, just the ones that you need. So what do we do then? Then we probably just move around the scene nodes, right? Yeah. So by we apply the steering values, we just move around the scene nodes, and then we call AG update joint drive goal pose, which is sort of a mouthful. And what that does is it essentially makes the physics here match the visuals. That's the beauty of that articulation graph thing. So I don't need to manually move these kinematic bodies around. They have their joint, they're jointed to the arm, but when I move the arm around like this, the physics are sort of like moved around as well. You might be wondering, like, well, okay, what's the big deal with that? Well, that's not necessarily automatically taken care for you by physics engines like this. Like, yes, you can join things together using joints, and then using like motors, you can sort of like drive them around, and that is essentially what the articulation graph is doing. Specifically, it's using like, I think, DOF 6 joints. So the 6 degree of freedom joints, yeah. Create DOF 6 joint. And then it drives that joint. All right. So something like this. So we create a new component for the new crane, and we create a new, shall we say, 2-joint crane arm thing. So basically, like this guy, 2-joint crane arm this is not a component. This is just a data type that you can put on a component if you want to. Like I said, this thing is pretty big, which is a little annoying, but we can take this and make a new one, which uses the articulation graph. And then we throw one of these guys onto the new crane, and that should be like a really good, really solid base for this new crane. And then when this works, I can essentially like make the other crane use this one as well. That should be good. That should be good. And then that's sort of like the complicated part of this. The actual force field for like sucking up dynamic objects and things like that, that should actually be really, really easy. Like I said, much easier than this old crane that we have here. But enough talking. I'm gonna go get a glass of water, and when I come back, I'm gonna start building this thing. So one thing that we perhaps need to check here still is like, how do we actually drive the crane? So this thing doesn't have more than just the driver and the cargo crane rolls currently. But of course we need to have a third one for the new gravity crane. I don't know what to call that actually. Like it's a very sort of sci-fi thing. I'm thinking just as sort of like a work name, we'll just be calling it. Whoa, what is happening? We have some we have some physics glitching out a little bit here with this crane. Oh well. Yeah, so as a work name, I'm gonna call it the gravity crane. This is the cargo crane, and that would be the gravity crane. So if you have this cargo crane role selected, all the controls control the crane, like this. You can just press Y and it will reset. If you have the driver, then you control the actual vehicle. We have the little guy there behind us, making us somewhat stuck. So how does it actually route those inputs? Let's just pause the game there and see how that actually works. I think if we go to the asset browser here and we have a look at the blueprint for that vehicle. So we have mother here, and this should have some sort of component for listing those roles. Just scroll down. Here we go. Driver and cargo crane. So it has like a type, and it has a position, which was supposed to be. That's not something I've actually really ever used. But it was supposed to be sort of like if you have the driver role, the camera kind of like orbits around the vehicle like this. And my idea, which I so far haven't implemented, is like if you switch to this cargo crane, the camera would sort of like orbit around the cargo crane, because it still orbits around the center of the vehicle. But it would orbit around this part of the vehicle instead, to give you a better sort of view of what's going on. So that hasn't been done. Also, we don't have any gravity crane roll thing here. That's something that we'll have to add. What if we look at this in its raw form? So these are all JSON. You can see driver. Yeah, here we have the same thing. So cargo crane and driver. So they're represented here by their string form. And I bet if we go into means data and metadata, there's probably a type here for vehicle, probably vehicle avatar component, I would assume. Vehicle avatar role is the type. Yes, it's an array, you can have maximum 8. So types has vehicle avatar role. And here we have driver, cargo crane, attractor crane. Oh, attractor crane. Yeah, that is the thing that I was actually calling it previously. Let's just call it gravity crane for now. Gravity crane. Now if we reload this blueprint file, I think it should... Oh, actually we need to call reload component UI definitions. There we go. Now if we reload this thing, now we should have the ability to give it the new role. And now let's see what happens if I just give it that and I don't change the code at all. Might just be confused. So, cargo crane, let's add one more. We call that gravity crane. I'll just leave the role position as it is. Gravity crane like that. Yeah, we need to call it something similar here, or otherwise we're probably gonna get some sort of JSON error, JSON parsing error. Let's see what happens actually. So if we set that as the avatar, and then we get driver twice. Okay, that's not good. Let's call that gravity crane. And it should actually be gravity crane there in the enum as well. The reason I have this as a function here is that, as this comment says, we need to localize these names eventually. I just haven't done that yet, so I just have a function for getting the display name there. But yeah, gravity crane and gravity crane there as well. So, we should really make a sort of a debug shortcut for setting that as the avatar. Actually, I think I can just do this gamestate.set avatar and copy that command and put it in here like that. Now it doesn't do anything because we already were the avatar of this, but now if I restart the game, I can access that quickly from my command history. So just open the console, press up, and then enter, and there we go. Now we are the thing. So gravity crane. Now you can see that none of my controls do anything. I can still rotate the camera, but I can't do anything else because now we are controlling nothing. Because we don't have the gravity crane. We have the cargo crane, and we have the driver. Yeah, we probably need a better name for it than gravity crane, but for the time being, it's probably fine. So now if I engage that roll, I'm gonna drive off the cliff. Not that you really can do that anymore because I have collisions here preventing you from driving off the cliff, of this particular cliff. Okay, so that's good. So what does that actually then do? Remove the correct input context here when we have it, and here as well. That should actually be add the correct input context here. So here is a function called onAvatarRoleChanged, and we have input contexts for all of these things. So vehicle driving controls, world interaction controls, cargo crane controls, gripper arm, truck bed controls, all of that. So you can have like a button do one thing when you are operating the crane, and that same button doing something else when you are operating the truck bed, for example. And the actual input IDs that you get out of that depend on which of these contexts you have enabled at that time. So the previous role gets removed, then we set the new role, and then we add it here on the input system. That looks good. Okay. Cargo crane controls, though. Since the controls will be essentially like exactly the same for the gravity crane and the cargo crane, I wonder if we shouldn't just like use the same input context for that, right? Because see here, cargo crane, we have forward, backward, left, right, up, down, magnet toggle. Well, this would be, activate. Then we have extend cable, retract cable. We don't need those for the gravity crane, but I mean we just don't read those, right? And then reset pose is also useful for the gravity crane as well. So we should just be able to use these ones. So what would happen then if we quite simply just push that? I think what will happen is that we will also be controlling the cargo crane, right? Which of course is not something that we want to do. Hey Caesar, welcome to the stream. And yes, I did tell you to come say hi, so you have successfully completed that objective. Right, so let's see. So now, controlling this controls the actual driving, just as we expect. If we have the cargo crane context, we control the crane, as we expect. Gravity crane context, we also now control the crane, right? Because what will happen now is, depending on which input context we have enabled, certain input IDs will be fired. So if we go have a look at the cargo crane component, and we can use something like input.get. It's actually not. It's not called that. It's called get input range. Right. So cargo crane left, right, cargo crane up, down, cargo crane forward, backward. The cargo crane just sits there on the vehicle and gets this pre-tick, update pre-tick, and there's probably also a tick, yes. So pre-tick happens before the physics, tick happens after the physics are stepped. And so if we have the correct input context enabled, then these input ranges and actions and states will quite simply just be fired. So the cargo crane doesn't really care that the correct role is not set. And so the question is, how should we make it care? Because I really don't want to add like just identical input IDs for that other crane when this one's input IDs work just fine. That seems kind of unnecessary. I think what we could do perhaps is figure out which component is actually keeping track of that role. And it's probably the one that we actually set that role on here. If we go back to the asset browser once again, probably shouldn't have closed this. Let's have a look. It's right, it's here. Vehicle avatar component. This guy most likely keeps track of which avatar role is actually enabled. So if we go and find that vehicle avatar component. Oh, this is a big one as well. Oh boy. Let's see. Yeah, this guy just does a whole bunch of things. But I wonder if it does that specific thing. Might be that one, might be the in-game menu logic. Let's have a look here. Avatar role logic, that looks like it probably is what we're looking for. On highlighted role index, menu visibility. Active role index. Yep. When the menu close to the active role is set, this happens only on the server. Search for that. Right, so vehicle avatar component actually does have a function here which is called on active avatar role active role index change on client. Yes. Okay. And we have a print here that we can actually uncomment. Because of course the input is only read on the client. The server can't actually read input because it doesn't know anything about input really. Well, it does know about input IDs, but it doesn't know like did someone press the keyboard or the gamepad or whatever. That's like a client only thing. But if we move that to the side and then we again move here to this guy, we should be able to see, yeah, active role now dot cargo crane, dot gravity crane, dot driver, that sort of thing. Alrighty then. So that means that this vehicle avatar component guy knows about that, and the vehicle avatar component is created on both the client and the server. And the cargo crane component is also, I bet, created on the client and the server. Yes. Cargo crane component actually can't be created on anything else. So that means that the cargo crane component could, at least in theory, get a pointer to this vehicle avatar component guy and ask it, hey, am I supposed to be active right now? And only if it actually is active does it care about those inputs, right? Means gameplay input manager. I think this is probably, yeah, this is the exact function that we just in, where we set this. Yeah, so that's something. This of course only runs on the client, right? This doesn't actually run on the server at all. Yeah, I wonder if we should probably somehow keep that kind of in sync between the client and the server. Because the cargo crane definitely runs on both the client and the server, and it does read the input on both client and server as well. In fact, I think the collisions are only actually created for it on the server. So if you have both the client and the server physics visualized at the same time, the green ones are the client physics, and the yellow ones are the server physics. So you can see that there's some green ones here on the actual cargo crane there. And if we remove both, we enable the client ones. Yeah, the crane clearly doesn't get any collisions on the client. It's a server only thing. So now we have them here. Right. Yeah. Yeah, this turned out to be a little bit more tricky than I anticipated. I haven't done gameplay programming in a pretty long while actually, so I don't quite remember how this works. But I think this is regardless of how complicated this turns out to be, this is the right thing to do, is to actually use the same sort of input IDs. Where do we have the input? Probably here. It's the right thing to do to use these same input IDs for both the cranes, rather than having like this. We have a cargo crane, and then you would have a separate one for the gravity crane, or whatever we end up calling it. I think the correct one would be just to have these be called, crane. So we can remove all of that, and then we quite simply call this crane controls, like that. Now ZLS rename functionality has been a little bit flaky for me, so I think I'm just gonna do renaming like this by hand. I actually updated my Zig version today to the newest one, so there might be some funkiness related to that as well. We're just gonna have to see. And then input mappings need to be changed as well. Crane. Yeah, so cargo crane here, we can just do a rename and call it crane. All of those. I think we might have to restart CLS to get it to actually understand that it's all good. Yeah. Yeah, CLS has been a little flaky with this lately. That if you rename something, like, it doesn't understand that it has actually been remapped, then you can't navigate to it. You can't do anything else. It's a little weird. there's a C missing there. There we go. So left, right, up, down, forward, backward, reset, and magnet toggle, and extend, retract. And maybe we should call that something else. We should call it like toggle active or something, right? Crane magnet toggle, do a global search for that, and then call it toggle active instead. So then it will work with our new crane. Something like that. Let's make sure this actually builds before doing anything else. It does not. What do we have? Cargo crane controls. Right. So cargo crane controls is now just crane controls, and this is the name for the context that contains all of those. You know what? You know what we could do here? I think we can use the same exact IDs, but we can quite simply create another input context for it, right? So this would actually still be cargo crane. What? That's not what I wanted. How did undo just like undo all of those? I don't know. I don't know. It should build now though, shouldn't it? Yeah, now it builds. But of course it doesn't really fix anything, we just rename some stuff. Still though, we should be able to have two different contexts. So one for the cargo crane and one for the gravity crane, which shouldn't mess with that at all. The reason I don't want to, or one reason I don't want to actually add new IDs for that, is that that actually takes up space in an input buffer that needs to be sent from the client to the server, essentially every frame or every update, every time the input is read on the client. I think it actually writes the size here somewhere if I can find it. Yeah, it's not that one. Maybe it's commented out. I had a printf at some point that actually prints that. But yeah, that's neither here nor there. The cool thing here is that we should be able to just map those same inputs. So this would still be crane something, crane forward, backward, not cargo crane. They would work with all the cranes. But then we would just map them to two different input contexts. I'm sorry if this is super confusing. I'm I'm sort of trying to remember how all of this works. So here's what we've actually done. We've renamed the context from cargo crane controls to crane controls, and then we renamed all of the inputs from cargo crane something to crane something. We leave this as they are, but we'll actually revert this context stuff. So we have cargo crane controls, and then we'll have gravity crane controls. So now if we search for those, we basically like redo these things. Yep, like so. And we can just add a new one here. So this would be now then 44. That would be gravity crane controls. That would be 42. No, 43. I just have the number here because ZLS doesn't really give it to me like you would sometimes hope it would. You can see that this is 32, and that's because this is actually a constant. But then later on, if you debug the game and you see that like, okay, input context 41 is enabled and no other one, you can quite quickly see here that, okay, this is gripper arm controls or whatever. That's why I typically just write them here. So now we have cargo crane controls, gravity crane controls, and we can actually use it here. Gravity crane controls, and there as well. Oh, access denied because it's running, yeah. Of course. Having second thoughts about this, but we'll see. We'll see. Maybe it'll be fine. So now if we do gravity crane and we move, nothing happens. That's what we expect. We need to go to input mappings and actually map these guys to something. And what we map them to currently is cargo crane controls. So we would have to do the same thing for the gravity crane, except we could leave out these cable ones and those ones as well. Yeah, I think this will actually be good. I think this will actually be good, and the reason why is something I'm going to show you in a bit. Now that we have a separate gravity crane controls, we can do just this. We can remove the cable ones from here and from there, and that's that. These are just like, this is temporary code for mapping these two buttons. There will be like an input remapping menu, kind of like you see in most games at some point. At which point these will all be data driven, but like I've just mapped them to some kind of sensible inputs for now. Anyway, with this, now that we have two separate contexts, we can have the cargo crane actually check if the context is enabled or not before actually doing anything. So now if we run the game, we can see that, okay, cargo crane controls the crane, but gravity crane also controls the crane. So now we're back to the same problem we had previously, but now we have the tools to actually solve it. So let's make sure we have all the places in this file where we're actually reading input, and we can just search for get input something. So get input range, get input action, and get input state. It's all here in this one thing here, right? So pre-tick. If we are on the server, pre-tick can apply inputs to the arm. And that's it. We don't do anything if we're on the client apparently. All right. So if we are on the server and basis input is game input context enabled, we can call this means input context ID cargo crane controls. Again, we need to, damn you ZLS, cargo crane controls. There we go. Yeah, that should be good. So we can use the same input IDs, but just like not read them if we are in the wrong context. This should work. So cargo crane movement, and then no cargo crane movement. Excellent. And that of course means that now if we add another component to this guy, say a gravity crane component, we can just read that one instead, right? And that should be good. Maybe as a fun first little thing here, we'll just add another one of those gravity, another one of those cargo cranes here. Let's just basically copy paste the cargo crane and add it here on the side, and then I'll just check that other input context. Then that should mean that we get two different cranes that kind of like behave the same, but they obey different roles. So gravity crane component dot zig, and then we'll just take all of this stuff, plonk it there, and then we'll replace all of that with gravity crane component. Kind of like that. And then this guy will, again in the pre-tick, we will just do gravity crane controls, like so. The only other thing we need to do here is we need to actually register this component, and that is done by quite simply coming here to the components list. We can find the other cargo crane component is right there. Just copy paste this and add gravity and then that's the important part, add it to the list there. Let's make sure that builds. Yep, that builds. So now we should have that usable. We will want to do some copy pasting here as well. We want to do a cargo crane component. We want to copy that UI definition to its own thing again. Gravity crane component. So what the UI definition does is that when you are editing a blueprint like this for the mother, for example, you have these settings here that you can do. Oh, yeah, we actually get a warning here, but the color is a little difficult to read here against the background. We need to actually call this gravity crane component and gravity crane, like so. So the UI definition tells us what sort of settings you can adjust per component here. Now if we reload this, yeah, now we got rid of that warning there. So if we go to the mother, it's a really complicated vehicle. It has just a whole bunch of these guys. And where's the cargo crane? Unstockifier, nav mesh component, com radio. Cargo crane is right there. basically what I'm looking for here is like, is there a place where we're defining like where in the local space of the vehicle that crane appears. So like if we open the preview here, you can't actually see it here. It's only created in the game, but it kind of appears here on this hard point. So I wonder where that is actually set. Is that just like hard coded into the actual code itself? It might be. Let's see, gravity crane component probably has some like parameters and things. Properties. Arm. Alright, here we go. Some of these should probably be exposed to blueprint properties. Yeah, no shit. So arm root position, this is exactly what I was looking for. This is where in the local space of the parent object, that would be the vehicle, to put the crane. Look at that. So okay, the first thing we want to do now here is actually expose these guys as blueprint properties for the cargo crane, right? So where will it actually appear on the vehicle when it will appear on the vehicle? Because like technically you could add one of these cargo cranes or gravity cranes to another vehicle or like a building or whatever. They don't necessarily need to always be placed there where they currently are. So arm root position. Let's expose that as a vector that you can set here on the cargo crane component. That's kind of important. We also basically need to expose some of these other things, but I don't necessarily need to do it right now. We can just expose that one thing for now, and that will allow us to create that other crane, and then we can play with that a little bit. So how do we do that then? Well, let's think about this for a little bit. I don't want to modify this now. I want to make the change here in the cargo crane, so the older crane. And then when this stuff works, I want to bring it over to the gravity crane as well. So let's comment out the gravity crane for now from here and from there as well. And I'm just going to delete that completely because I want to do the same thing again. When we have the cargo crane component, sort of the stuff exposed here, so we can actually move the crane around the vehicle, essentially. Then I want to copy paste this guy, if that makes sense. So blueprint properties. What is that? Well, it's basically this cargo crane component properties. It has a boolean and it has two U32s. And you might be able to see that, oh, it's actually the same things we have here. We have a boolean, update volume spheres, we have arm end volume sphere index, and magnet volume sphere index. Those are the two U32s. So we quite simply need to add a position here, a vector tree, to be able to adjust that. Like where on the vehicle does this crane actually like attach to? And what do we call that? It's called something like root position here in the actual parameters. But maybe we can call it something a little more clear, something like crane attachment position or something like that. So crane attachment position, that's a vector tree. 0. Why not? And the way I typically do this JSON parsing is that I have this kind of like inner object here called props, which has the exact members matching the JSON data that I expect to, and I typically represent vectors as arrays. So an array of 3 would be like a 3-dimensional vector, an array of 2 is a 2-dimensional vector, etc. in JSON. So this would now then be an array of F32s, right? So F32 like that. I think that should be everything we need to do. If we just have this member here, and then we tell the standard JSON parse from slice leaky that hey, we want one of these props things out of the JSON data, then it will be smart enough to figure out that okay, the array is actually like this guy here. And then we can do crane attachment position, and then we can do a vec3 from init from JSON array. No, init from slice, I think that's what we want. And from slice, props dot crane attachment position, something like that. Let's see, is that how I have done it before? Yeah, it's exactly like that. Cool. So I think that's everything we need to do here on the code side. The only thing we need to do is still use this. So blueprint properties, if your component has them, they get sort of automatically assigned to this blueprint properties member here. And that member is an optional pointer. So what I typically just do, if I kind of like expect to have them, is I do basis assert that self.blueprint properties ain't null, right? And then after that we can do VP props, just a shorthand for that, and that would be blueprint properties dot question mark. And now this dot question mark just tells the compiler that hey we expect there to be something in that optional. Give us the sort of wrapped value. So if you have an optional pointer, you just get a pointer out of that. And from BP props, we can quite simply just read crane attachment position. Right. That looks good. So I think that's all we need to do on the code side. Then we just need to add this to the UI definition, so that actually shows up there in the UI. Again, let's just delete that gravity one for now, and let's make sure it works in the cargo crane first. Do we have any vector 3s? Yeah, there's a vector 3. That looks good. So we give it a name. Typically I use this like snake case here, so that would be what was it called? Attachment position. Crane attachment position. Crane attachment position. It's of type vector 3. The default can probably just be 0. So 0, 0, 0. And we give it a nice looking name. See. Position, like so. The description is like where in the local space of the parent object does the crane get attached, right? And then the JSON name is important. This needs to be, you know, exactly that, crane attachment position. And then this just tells the system whether or not we want the value there in the JSON, regardless if it is default or not. And typically that's a good idea to do. So now that we have that, if we reload the UI definitions and we open this thing again, and we click on mother, and yeah, this UI is really slow. Oh, okay, error loading blueprint properties for component blah blah blah. Yeah, I know. That's because we haven't actually rebuilt the UI, or the preview here was running the old version of the game before we actually made this. Yeah, you can see we got the access denied when we tried to build that because well, it was running here, so it couldn't actually figure that out. But now if we go down to the cargo crane is right here. Here's crane attachment position. So now if we save this and we run the game, the crane should be right in the middle of the vehicle, and it should be wonky as all hell. There we go. It is wonky as all hell. But it works exactly how I meant it to work. Meant for it to work. So that's good, at least. Let's have a quick look at what that vector used to say. So it used to say 3, 3.2, and minus 9.877. So if we put that in here instead, over there, and these need to be semicolons, like that. Now we should have it in the same place as it used to be. And look at that. It looks the same as it always did. And it works the same as it always did. Good. So now then, now that we have this done, now we should be able to create that other crane. So let's start by doing this part, because this is kind of simple. We need this to be gravity crane component, and we need it to be called gravity crane component here as well. And then name suggestion is just something that you can give it a suggestion, and then it will figure out a unique name based on that. So this thing, and copy it over to this thing, and then do the replacement here again. And there we go. That's all we need to do, and then we just need to undo this commenting out of the registration here. Oh, one thing that we can't forget is to actually read the correct input context, right? This thing that we added. So let's switch that out for gravity crane controls, and then build that. So the only thing we need to do now to get a second crane added to the mother vehicle is to come in here. Again, we need to reload the UI definitions because we keep changing them. And we go to mother. And we can look at at that cargo crane. Make sure we get the correct flags there. Let's see. There we go. Specifically the position. And then we can do component. And we should have gravity. Look at that. Gravity, and it suggests the component name that we gave it as the suggestion. It adds it as the last one. And we can quite simply, let's add that to like -3 to put it on the other side. And I think I'm gonna make it like 1 point, maybe like 2 along the x-axis. Something like that. Let's not do any update volume spheres because it's like we don't have any of those spheres. The spheres are there to basically help us with some like proximity, like distance calculations. Error loading blueprint property for component gravity crane component missing field. Okay. Which field is missing, I wonder? Oh, it is actually... You know what? I bet it's actually the thing that we just talked about. I bet it's actually... Yeah, this is a bug. If that is the case. Let's put 5 and 6 there as well. Now those two components will be sort of fighting over those spheres there. It can't be helped. I think that's a bug that I haven't realized that I actually have. Oh, look at that! I almost sort of managed to hit the spot that I was going for, because it's kind of sitting almost where it was supposed to sit. I think it just basically needs to be moved a bit to the side still. But that's cool. So now we can see that okay, we have 2 of these cranes, and we can control the cargo crane just like we can normally, and we can control the gravity crane with the second roll there. So that's interesting. I do wonder if we should make the front crane maybe a little smaller than the other one. I think they should sort of like look pretty different, because like the other one will be this sort of weird gravity crane thingy, while the other one is like it's a classical magnet crane sort of thingy. But let's see if they work. So if we have the cargo crane, let's maybe lift up that box over there. Bonk. And then we do the gravity crane. You can see that it's right. You know what? We can't we can't extend that cable, and that is specifically because we didn't bind those keys for it. So we need to actually lower this magnet down there. Now we can lift it up. And look at that. It does work. It does work. It is a little awkward to have a crane here that close to the front, where it can't really make all the same maneuvers as the one in the back, but yeah, I think that kind of makes sense. And the crane is gonna be a little different anyway, so. But yeah, I don't think this looks particularly good to have two similar cranes on the back of this thing. It looks actually pretty bad. And if we reset the cargo crane, it should reset itself so that it faces forward. Oh, you know. Yeah. You know what, we actually... I think we broke one thing here with our input shenanigans. Because like there's a reset functionality which works in such a way that like if you have a crane like this and then you press Y, you can see the thing is now moving back, and now it will soon start rotating back into its rest position. I think now that we actually made that change with the input contexts, it means that the resetting actually stops. So if I click Y, and now I'm no longer doing anything here. Now if I switch to driver, you can see that now the resetting stopped. Because I think the reset mechanism actually uses inputs to do the resetting. So that will actually fail then. Yeah. Right. That's a bit stupid. Yeah, many of these sort of things that have to be kind of, you have to make some of these mistakes to realize the problem here. Okay then. Well, as you can see, I've never had more than one crane on this guy, because like first of all I couldn't actually specify where on the vehicle the crane should go, and second of all we have these input sort of conflicts, if you will, making some of these things a little tricky. But okay, yeah, you know what? I think I'm gonna have to have a little bit of a think about how these very sort of basic things will work. I think actually making the crane shouldn't be that tricky. But I think just like figuring out the best way to structure these very basic things, such as like how to route the input to the correct crane, they will take a little bit of a... Well, I need to have a little bit of a think of how that is actually going to work. So I propose that we call it a night today, and I will be back with another stream when I have, you know, most of these things that aren't either very interesting to look at on stream or require me to just like, you know, mess around and find things in the code. When I have those figured out and we can actually like work on the gravity crane itself, then I'll do another stream. And that should hopefully be more enjoyable to watch, because this was a little bit I don't even know what to call this. This was a little maybe too unprepared to give myself a little bit of healthy self-critic here. I think I should have maybe done some of these things beforehand, and only then actually stream this. Yeah, the nice thing about this whole thing here is that the collisions still work actually. Like, even though this crane is now sitting in a different position than the previous one, you can see that even though I'm sort of trying to like poke it through the mother vehicle, it kind of bounces off. That's not actually like collision detection doing that. It's just that there are certain areas that this guy is allowed to move, and certain areas that it's not allowed to move. And it's nice to see that I actually kind of set that up correctly, because it's just like sliding along the edges here. There's a little bit of jittering, and of course that magnet at the end there, which is not going to be in the final gravity crane, can sometimes kind of like jitter around a little bit. But yeah, I think this will be good. Anyway, I think this is a pretty good drop-off point for today's stream. I need to have a little bit of a think of how this is to be set up, and then I will do some of the groundwork for setting up that crane with the articulation graph. And then when we actually have the crane somewhat working and we can lift just huge amounts of those crates with the crane, then I'll do another stream. That's typically a pretty fun thing to do. Fun thing to mess around with and just experiment with. So do look forward to that if this looks interesting, at least in theory. Small reminder as always, if you would like to play the game, you can already play the pre-alpha 1 and 2 build for this game. If you join the Magical Games Discord, there's a link in the chat there, and also in the description below if you watch this after the fact. Pre-alpha 3 will be out soonish, and it will most likely be delivered over Steam. But for the time being, I ask people to come to Discord because the builds are rough enough that I want there to be a very low threshold to ask for help if you have any issues with it, or give feedback. Both positive and negative feedback is welcome. Let's try to make the game the best it can be, and all of that. So do check that out if that sounds interesting. Other than that, have an excellent continuation of your day, or night, or evening, or whatever it is, where you are. Until next time.